Whenever you're ready.
Perfect. Mr. Neumann, the CEO of Exechon Enterprises, how are you today?
I'm very fine. I'm a very happy lad today.
Thank you. I would like you to tell us who is Exechon Enterprises?
Exechon Enterprises is the results basically on 30 years of work, hard work in this technology. I started off exactly 30 years ago in my garage developing the first so-called parallel kinematic machine in my summer house. That's a long time ago, 30 years. We've gone through several developing phases, several business models. We become the leader of this technology, and about, I would say 6 years ago, we got the opportunity to start a cooperation with Lockheed Martin that has ended up in Exechon Enterprises that is now established in Abu Dhabi. And that's a short answer to that. Could be, I could spend a day to elaborate on.
Thank you. And could you please tell us about the strategic focus of Exechon Enterprises?
Absolutely. The strategic focus of the Exechon Enterprises is quite different from the strategy we had before. The strategy before we entered this incorporation has been to sell licenses of this unique technology, and the machines, even though unique technology, has always been made out of traditional steel castings, traditional manufacturing methods. The new XMini that you see behind me here is totally, completely made out of carbon fiber. And that is a result of a cooperation between us and Airbus and Boeing to meet the future demands of manufacturing of aeroplanes. And in this new strategy, we are no longer licensing this technology out. We're actually going to manufacture this. So we are setting up a manufacturing facility in Abu Dhabi to produce this in hundreds and hundreds or even thousands of numbers to be distributed and integrated worldwide.
And could you please just tell us more about the XMini? Why the XMini? What makes it actually a paradigm shift in automated aerospace manufacturing?
Well, it actually started off about, I would say, 4 years ago, 2012. Almost simultaneously, both Airbus and Boeing approached us and told us that, hey, we have to double production of planes by 2020. And we cannot double the number of hangars, we cannot double the number of people, we cannot buy $100 million automated equipment. We need to boost the existing production. And the only way they saw it is to have some small, tiny little machine that they can put in and replace the people inside the jigs and fixtures, inside wing boxes, where it's not only inefficient with manual work, but it's also not good for health to have a people drilling in a wing box, hazardous material like carbon fiber. So it has a dual thing to improve production and release the people from really hard work. And to do that, they need a machine that is portable, mobile, that can go to the parts instead of the parts going to the machine, that actually can be utilized in existing jigs and fixtures, as I mentioned. Requirements there means light, but light is not enough. It also have to fit in. So you can imagine when you go into wing box, there are small tiny holes. Inside is big, but to go in is not. So one requirement was take it apart, move it inside a wing box or a jig, and put it together and push start. So that combined with the weight has actually been realized now here, and that's a true paradigm shift, that we actually take the machine to the parts instead of the parts to the machine. That also gives you other big advantages for the future. You can take the machine in the field. You can repair a plane, a fighter jet, anywhere in any country, globally, whatever. You can take it to an oil platform to machine and repair equipment on an oil platform. You can take it anywhere in the world, even to the moon, and do machining and assembly. Never been done before, not even thought about before, but we've done it now and it's a reality.
And who are are the audience? Who are the audience the XMini can target? Like different or specific industries?
I think machining and robotics is a traditional conservative industry. So we have to start with the obvious ones, which is the guys who actually asked us to develop it, which is the aerospace industry. And I think that's quite easy to...
Sorry, can we just wait until that noise is finished and we'll
Yeah.
start that one again?
You know where that
Because
noise is? Can we ask them to not do that?
Can you...
Is it the machine?
Can I ask them to do so?
Which...
it's not too bad, it's just because it ran into
Benny,
something as a question.
can you
so
find
many
out who
minutes.
do that terrible noise? And ask them to hold a little bit?
See the videos. Yeah.
Thank you. So we can go again. It's not happening now, so hopefully.
So could you please tell us who's the audience the XMini is targeting?
Well, the obvious audience initially is the guys who actually asked us to develop this, which is the aerospace, the Boeing and the Airbus guys. But during this development, we have been, obviously the rumor has gone around for years what we're doing. So we see now that we've been approached by the oil and gas, we've been approached by automotive. So I would say, if we talk about a paradigm shift, it's actually making people think differently in the way they process things and manufacture things today. And that goes across most of the market areas. And we even talk to the mobile phone and mobile phone and tablet manufacturers who are going from flat 2D phones to 3D shapes and need 5-axis. So we talk about laser applications, we talk about assembly, and it's a lot of different applications that we will go. I guess we will go initially where we have the fastest payback on it, and then we grow from there.
It must took a long time of effort and research and time. Could you please tell us about partners who made that happen?
Yeah, you're quite right. This has been a challenge. I mean, the technology by itself, I said I've been doing it for 30 years, which is almost half my life. Exactly half my life. Don't tell the audience that. So building it from design point of view, from functionality, I had no issues with that. Adding composite carbon fiber into it, I only read about it. I'm flying with the planes that built of it. I had no idea. Actually, nobody in the world had an idea about how can you do it. Can it be used for machining? Will it work for machining? Nobody could tell. So it'd been a nervous, brain-wrecking way to where we are today. And as late as 2 days ago, I still didn't know if you could machine with it. Now we know. But yes, we have been luckily supported by a team of suppliers from screws to motors, controllers, spindles, most important by AMRC where we are today, we have a team of 27 engineers here working for us for 2 years to develop the carbon fiber parts, going through design, calculations, testings, verifications. Still we didn't know. Nobody could tell, but yeah, it works.
And how that can be cost effective? How can the XMini make the difference from cost perspective?
Well, people think that, number one, oh, it must be an expensive machine.
Exactly.
On the contrary, if you look at that machine there, that machine we built in steel, it's about 1.5 ton. That machine there is 250 kilo. Carbon fiber per kilo is about 10 times more or 20 times or 30 times more expensive than steel. But if you use that much less kilogram, if you 10 times more, but you use 10% of the weight, it's no difference. And also machining it, you can form it differently. So in the end, our target here is to have this not only as a new technology for new applications, but also lower the cost substantially compared to conventional machine tools.
So if I was a 5X machinist, why would I buy an XMini?
Because it's so funny to run and it looks great. No. For a 5-axis machine, it could be actually scary. And not only this one, all my PKMs for 30 years, first sight, a machinist or operator, we call them, gets a little, oh, what is this? But honestly, I tell them, put your hand, cover the 3 legs and look at the head. It's a traditional standard CNC machine. It's programmed, it's run by a Siemens 840D. It's programmed, you can actually download a traditional machine NC program into the machine and run it. So it's nothing to be scared of. On the contrary, the operator can develop his processes in a much more efficient way because of the dynamics, because of the speed and everything on it.
I would like to thank you very much for this very
Thank you very much.
Thank you so much.
Thank you. That's okay?
Yeah, it's really good. Thank you.
Is there anything else